8.8 exponential and logarithmic functions, what we're going to do is we are going to use a new equation. So it says in section 8.1, we have the formula for compounded interest, and it's A equals P 1 plus R over N to the NT. Okay, remember, this is where it's compounded a certain amount of times. There's going to be a new formula, and this is the last formula that you need to know. A equals PERT, PE to the RT. This is when interest is compounded continuously. This formula is only used when you see or hear those words, compounded continuously. If it's compounded any other amount of times, you would go back to our original, which was this one. So our first question says $1,000 is invested in a 3-year bond that pays 5% per year, compounded continuously. So we are going to plug into our equation. So we invest 1,000, so it means A equals 1,000. Then we have E to our rate, which remember, anytime we have a rate, we move it 2 to the left. And we don't know the final value. Oh, nope, sorry. And it's a 3-year bond. So that times 3. Now, if you plug this into your calculator correctly, you end up with your final answer. $1,161.83. For number 2, it says, suppose you deposit $700 into account paying 3% annual interest, compounded continuously. So this is where we are using PERT. What is the balance after 8 years? So first we're going to plug it in. A equals 700 e to the 0.03 times 8. And then we just plug that into our calculator. 700 e to the 0.03 times 8. 889.87. Now it says, how long will it take for the account to reach 12,000? This means you're finding time, right? So we're finding t. So this is where we're going to have to do some math and solve. So we have 1,200 equals 700 e to the 0.03 t. So just like we've been doing, what we need to do is get e by itself. So in order to get e by itself, we need to divide by 700. That ends up giving me 1.714, and it keeps going on forever. Now I want to keep that specific value in my calculator. I don't want to round it, because if I round it now and then round it later, I'm rounding too many times for my final answer. So if I want to solve for t now, I need a way to bring it to the bottom, right? And the way to bring it to the bottom, typically we can log both sides, but remember, ln cancels e. So we're going to ln both sides. So I now have ln of this equals 0.03 t. So I'm going to use my calculator and do ln of that number. And that gives me 0.5389 and so on. So we now have 0.53899 ... equals 0.03 t. Then all I have to do is divide by 0.03. And when you do that, you end up with the answer of 17.96655. Now again, we're talking years, and I'm okay with really anything. This one's so close to 18, so I would definitely round it to 18 years. But depending on the decimal, you can round down, you can round up, you can just leave it as a decimal like 17.9 years. I'm fine with all of those. And then it says, how much money would you have to deposit in order to reach a balance of 1,500 after 12 years? That means I'm ending with 1,500, and I don't know what my initial one is, which is P, and that's to the 12. Actually, we have our rate first, so 0.03 times 12. So this time it's a little different. I almost have P by itself. The only thing that's happening is it's being multiplied by e to the 0.03 times 12. Okay, and 0.03 times 12 gives you 0.36. So this is actually 0.36. So all I have to do is get rid of e to the 0.36 by dividing it over. And 1,500 divided by 0.36, or sorry, e to the 0.36 gives me 1,046.51. We are going to just look at these four formulas that we know, and I'm going to write them out and we're going to talk about them again, and then we're going to use them to help us answer some questions. So if you remember, your exponential growth would be y equals a times 1 plus r to the t, all right? And exponential decay, y equals a times 1 minus r to the t. So this is just saying when it's just growing or it's decaying. There's no compound part of it, so that's when you use these equations. Now, when it starts saying compounded, when it's a compound interest, that means that you would use A equals P times 1 plus R over N, the NT. And then if it's talking about compounded continuously, you need the word continuous, all right? Whether it is growth, decay, or interest, or anything like that, if they talk about continuously, then you will use A equals per t. And all of these are set up very similarly. Obviously, the last one's a little bit different because we're using E. And remember, E is something. It's not something that you plug into. It stays E. So these are mixed review questions that can talk about any one of the formulas. You have to decide, and that's something that you will see on your final. These are types of questions that you'll see. There's a couple in multiple choice, but there's also a few that are free response. So you deposit $1,500 in an account that pays 0.3% interest, compounded continuously. Okay, that's the giveaway. How many years will it take for your money to double? So in this case, compounded continuously means we're using A equals per. So I know I deposit 1,500, which means this is 1,500. And then e to the r, if it's 0.3, remember we moved 2 to the left, so 0.003. And it says how many years, so I know we're looking for t. But then there's no other number given to us. But we can figure out what that number is because it's saying for your money to double. So we would take 1,500 times 2, which would be 3,000. Now, technically, when you do this, you can jump straight to this next part instead. If our money is going to double, that means that when we divide 1,500 over, we would get 2, right? Because 2, and then this technically is a 1, right? So that would be double. Okay, it'll always reduce to that if you're doubling, but whatever way you want to go is fine. All right, so from here, all we have to do is solve for t. And the way to do that is to ln both sides so that our e cancels. When that happens, remember, we can throw this in front, and we're left with ln of 2 equals 0.003 t. So all we have to do is then divide by 0.003. If you type that into your calculator, you end up with $231.05. Oh, not dollars. We would say years. So that's basically 231 years. Okay, because 0.05 is a very small portion. So I'm going to round it down. Then we have number 6. You purchase a stereo system for $830. The value of the stereo system decreases 13% each year. What is the value of the system after 1 year? So it's talking about decreasing, doesn't say anything about compounding. So that means this is our exponential decay. So y equals a 1 minus r the t. So then we plug in. We have 830, 1 minus our rate, which is 1.13, and then it's to 1 year. All we have to do is type that in. If you do that correctly, you end up getting 722.10. I definitely encourage you to try these next couple on your own, okay? As many as you would like. Do it on your own and then watch the video after, because all of these you should know how to do at this point. And you might not have to watch the video. You could potentially look at my work and see what's going on.